Hello learners. In this video, we are going to talk about how to solve numerical questions based on the topic reverberation. Reverberation is nothing but persistence of a sound in a room due to multiple reflections. Now, for how much amount of time the persistence remains in a particular room, that is termed as reverberation time. And here we are going to talk about how to calculate reverberation time of a particular hall. So let's take one example. The formula which is used for the calculation of reverberation time is known as Sabine's formula because it is given by the scientist W.C. Sabine. According to Sabine, the reverberation time is directly proportional to volume of the hall and it is inversely proportional to total absorption in the hall. So by considering this factor, we may get the equation T is equal to K into V upon A, where V is the volume of the hall, A is total absorption in the hall, and K is nothing but proportionality constant. The value of proportionality constant was given by W.C. Sabine as 0.161. Therefore, the equation becomes T is equal to 0.161 V upon A. To calculate total absorption in the hall, the formula is provided as summation A into S. If there are n number of objects, then we may consider equation as summation of A1 S1 plus A2 S2 plus A3 S3 like this up to AN SN, where small a stands for uh, absorption coefficient and S1, S2, S3. These are nothing but surface areas of the various absorbing materials present in the hall. So by considering this, equation will become T is equal to 0.161 V upon A1 S1 plus A2 S2 plus A3 S3 like this up to AN SN. Now let's take one example. The statement is provided as a lecture hall of 12 by 10 by 5 meters length, breadth and height respectively. It has average absorption coefficient 0.3. Then calculate reverberation time of a hall. At first, we'll see what is given data. So given data is L is equal to 12 meter, B is 10 meter and H is equal to 5 meter. Average absorption coefficient is provided which is nothing but 0.3 meter and it is asked to calculate reverberation time T. We know the formula T is equal to 0.161 V upon summation A into S. V volume of the hall. Average absorption coefficient is provided in the given statement. Surface area is not provided directly. So here we need to have the surface areas of the walls present in the room and we are going to consider the surface area of floor and ceiling in that particular case. So here the formula will become T is equal to 0.161 multiplied by V upon average absorption coefficient multiplied by 2 in bracket L into B plus B into H plus H into L. So by taking the values into the formula, we'll get T is equal to 0.161, 12 into 10 into 5 divided by 0.3 into 2 in bracket 12 length multiplied by breadth plus breadth multiplied by height plus height multiplied by length of the hall. So do the calculations and you will get volume is nothing but 600 for denominator. If we do the calculations, then we are going to get the values for reverberation time as 0.5 seconds. So here for the given statement, whatever is the reverberation time calculations, they are equal to 0.7 seconds. So for given room, the reverberation time is 0.7 seconds. So hope you will have understood this. Let's take one another example here. Little bit changes are done. So what are the changes that we'll see? In a rectangular room, the floor dimensions are provided, which are nothing but 12 meter into 20 meter, and ceiling height is also provided, which is nothing but 4 meter. The floor material has absorption coefficient A is equal to 0.2, ceiling has A is equal to 0.4, and for wall material average absorption coefficient is 0.6. And it is asked to calculate the reverberation time. Again, as like previous, the floor dimensions are provided, L provided, B provided, and H is provided. So from values of L, B, H, we may calculate the volume, and that will become 1200 meter cube. Here, there is no any average absorption term, but absorption coefficient of various materials are provided. Like for floor it is 0.2, for ceiling it is 0.4, and for wall it is 0.6. So according to that, we need to have the calculations for the total absorption in the hall. So formula again, T is equal to 0.161 V upon A. Volume we have already calculated, which is nothing but 1200 meter cube. Now for total absorption in the hall, we need to consider the formula like this: average absorption coefficient of floor multiplied by surface area of floor, average absorption coefficient of ceiling plus multiplied by surface area of ceiling, plus average absorption coefficient of wall 1, then its surface area, average absorption coefficient of wall 2 multiplied by surface area of wall 2, average absorption coefficient of wall 3 multiplied by surface area of wall 3, and average absorption coefficient of wall 4 multiplied by its surface area. So by considering the things here, for one wall the surface area will be, for floor the surface area is L into B, same will be the surface area of ceiling, L into B. For wall 1, say surface area is L into H, and that will be there for another wall. Two walls who are parallel to each other will have the same surface area. Then another two walls will have the similar surface areas that are nothing but B into H. So now by putting the values into the formula, you may calculate the things, and ultimately you are going to get total absorption is equal to 348. So put the values into the formula. Total absorption is 348, and the volume is 1200. So formula is T is equal to 0.161 divided by 348. So after the calculation, you will get the reverberation time is equal to 0.55 seconds. So here for the given statement, the reverberation time is provided as 0.55 seconds. So that kind of questions are there on the reverberation time. Hope you will solve some more questions, and thank you for watching.